All right, welcome back. We're going to move into lesson number 2 now, where we're going to look at the details of our feature templates. We're going to start by looking at the system feature template, what it's used for. I'm going to go through all the different options within the system feature template and kind of describe what those are. Then we're going to take a look at the logging feature template. We'll take a look at how the OMP template can be configured with OMP features. We'll take a look at the security feature template. We'll take a look at the BFD feature template and how we set up BFD features. And then we're going to take a look at other feature templates that can be configured on the platform. We're not going to go through every single one in detail, but some of these critical ones I'm going to kind of break down piece by piece and step by step. So the first thing that we're going to take a look at is the system feature template. Now we use the system template for all of our Viptela devices in our environment. We want to configure system-wide parameters for each of these devices using the vManage template. So the first thing we do is we create a system feature template to configure system parameters, and that's really what we're going to break down in this particular slide. Now I had mentioned in the last lesson that there were different icons to the left of each of these variable fields, and we can see the 3 different icons. Site ID is a host-specific or device-specific feature. The check mark here indicates that this is the default value that's applied in the template. So for device groups, it's blank. For the time zone, it's the America or Los Angeles time zone, and so on. The globe here indicates that these are global parameters that would be applied, in this case, the controller groups. And we're going to break down what each of these individual fields represent. So the first thing that would have to happen is to create a system feature template. We would use that to essentially create a configuration guideline, if you will, for all of the different system components. We would, for example, create an NTP feature template to configure things like NTP servers and NTP authentication. We would configure the organization name and the vBond orchestrator IP address on the vManage NMS and so on. So the first thing we're going to do is we're going to go into vManage. We're going to select configuration. We're going to go to the template screen. And then in the devices tab, we're going to click to create a new template. From that create template dropdown, we're going to select the feature template. And then from the devices model dropdown, we're going to select the type of device for which we're creating this actual template. If we want to create a custom template for a system, we select the factory underscore default underscore system underscore template, and then we click create a template. And then the system template form, like you see on the screen here, is going to be displayed. It's going to contain fields, for naming the template. At the top, we see that in the gray box there, the template name and the description, which are required. And then on the bottom, it's going to contain all the various fields for defining all the system parameters. Now, the template name field has to be unique for the template. It can be up to 128 characters, and it can only contain alphanumeric characters. In this case, we can see underscores as well, but that's the default template. All right. In the template description field, we can enter the description of the template. That description can be up to 2,048 characters, but it can also contain only alphanumeric characters. Now, when you first open up the feature template, for each parameter that has a default value, that's going to have that check mark next to it, and then whatever the default value is shown is going to be listed there. All right, and then we talked about device-specific configurations as well, which would be indicated by the host icon, and we can use a CSV file when we're attaching the device to populate those fields. We also have our global, which is indicated by the globe icon. So let's start first by kind of breaking down the basic system-wide configuration. To set up system-wide functionality, we select the Basic Configuration tab, which we see listed here essentially, and then we basically start to populate the parameters. Any parameter that's marked with an asterisk is going to be a required field. I'll kind of identify what some of those are. So the first thing you see listed here is the site ID. On vManaged devices, vSmart controllers, and vEdge devices, we're going to have to specify the site ID. This is a site ID for the overlay network domain where the device resides. It could be a branch, it could be a campus, it could be a data center. The ID has to be the same for all the devices that reside in the same site. And it's a 32-bit field, so it can be anywhere from 1 to 4.2 million, whatever, right? I forget what the number is, but it's basically 2 to the power of 32 minus 1. All right? So that site ID would basically be a value that you would specify. It's a mandatory field, and it would be a value that you would specify to identify devices that are in a common site. The next thing that you're going to see is a system IP. We talked about that a little bit earlier. It's a dotted decimal 4-part notated address, and it basically provides a fixed location of the device in the overlay network. That's going to get tied to things like the TLOC address for the device and the VPN 0 component, right? So typically we're going to use the device's loopback address in the VPN 0 VPN as this particular address, but we cannot use this address anywhere else. So it's kind of like a router ID in OSPF or BGP or EIGRP. It has to be unique to the device in the entire SD-WAN fabric. And again, that's a 32-bit dotted decimal address. That is also a required field. Now you'll notice that those are grayed out, right? Those are grayed out, indicating that those are device-specific parameters that either have to be manually configured or they have to be implemented in that CSV template so that they can be imported. The next is the time zone. The time zone is also a mandatory field. That's device-specific. That's basically the time zone of the device. Then we have our host name field. And the host name field is where we basically enter the name of the device, up to 32 characters. The location field is the location of the device. Now, host name and location, those are not mandatory fields. You can put them in, but they're not mandatory to deploy a device. The location can be up to 128 characters. Then we have the controller groups field. Now, this is only going to be implemented on vEdge routers. It lists basically the vSmart controller groups where the vEdge routers belong. And we're going to talk more about in our deployment section about how we set up controller groups. In this particular configuration, we can see that any device that's associated with this feature template is going to be in the controller groups 10 and 20. So we'll talk about that a little bit later on. That's actually not a mandatory field either. Neither is device groups. Description, also not a mandatory field. Basically a description of the device. The console baud rate. This is also something that's only going to be applied on our vEdge routers. You can have 1200, 2400, 4800, 9600, and so on. We can see in this particular case that we do have a check mark with a value specified, which indicates that the default value is 115,200 bits per second. Okay? Then we see the maximum OMP sessions. This is also a vEdge router only specification. This is going to set the maximum number of OMP sessions that a vEdge router can establish to a particular vSmart controller. And this is going to go anywhere from 0 to 100. The default value is 2 in this particular case. All right. Dedicated core for TCP optimization. This is only optional on 2 different devices, the vEdge 1000 and the vEdge 2000. And basically what we're doing is we're trying to carve out a separate CPU core to use for performing TCP optimization. So we modify those configurations, we click Save. There will be a CLI equivalent configuration that's going to be created under System. You're going to have different subgroups, clock, which would include time zone, console baud rate, controller group, description, device groups, and so on. All right. Now, to configure the DNS name or IP address of the vBond orchestrator, we would have to go into the administration settings, and then click on the VBON to set up that information. All right. Now, to configure the GPS location, which is basically the device's location, we would select the GPS tab, and then we would start to configure different parameters. We don't see, well, we see the GPS location listed here. It's actually not a separate tab in this particular case, but that would provide us the ability to enter the latitude of the device, which is a decimal degree value, and the longitude of the device, which is a decimal degree value. Setting the location allows us to identify whether, to the vManage NMS, whether or not a device is moved to a different location. So that can be useful as well. And then there's going to be a CLI equivalent that's going to be applied under System GPS-location. The next thing is interface trackers. We don't actually see interface trackers in this particular case. So let's go ahead and go to the next slide here so we can kind of, like we're scrolling down on the configuration screen. Now, I didn't talk about all of these features, right? VBON only, DNS cache, track transport, port hopping, and so on. You know, it's a little bit kind of beyond the scope of this course, but I'll see if I can kind of add some information for each of these fields. The interface tracker section, we can see that we have a name. The name allows us to identify the name of the tracker. The track option allows us to track the status of our different transport interfaces that go to the internet. So this is a very useful feature, almost like an IPSLA type feature where we're looking at the status of the interfaces. The name itself can be a 128-bit, 128-character name, and you can have up to 8 different interface trackers that you configure here. There should be, we don't see it right here, but there would be a plus sign that allows you to configure these advanced options and add additional interface trackers once you get through the configuration. The threshold value. Let me see, do we see threshold value here? Let me check the next slide and see if it's listed on the next slide. Nope, we don't have it here, but there are some other variables that we can set for the interface tracker. The threshold value, which you're going to see, is how long we're going to wait for the probe to return a response before declaring that that particular interface is down. That's going to go anywhere from 100 to 1,000 milliseconds, and the default threshold in that case is 300 milliseconds. The interval is how often we send out those probes to determine the status of the transport interface, and that's going to range anywhere from 10 to 600 seconds, and then 1 minute is the default in that particular case. We have a multiplier, which is basically the number of times that we're going to resend the probes before we declare that the transport interface is down. That multiplier defaults to 3, but it can be set anywhere from 1 to 10. Then we have endpoint IP addresses and endpoint DNS names. We don't see a lot of this stuff listed here. It would be kind of further down on the screen. Unfortunately, they didn't give us really the entire screen here, but if you're accessing a system or if you're configuring a system, I want you to be aware of each of these options that you have. So the endpoint type of IP address allows us to specify the IP address of the endpoint of the tunnel interface. This is basically the destination in the internet where the router sends probes to determine the status of that transport interface. For each tracker, you might configure either a DNS name or an IP address, which is the endpoint type specified as DNS name, and we would use simply the DNS name to point to the end of that tunnel interface. And that's, again, the destination. So this is the interface tracking feature, which is highly recommended, of course, is what you would set up to basically monitor the status of the VPN tunnel so that we can make policy decisions whether that tunnel is available or not. Okay, we're going to go ahead and click Save, and then we'll generate a CLI equivalent, which is also going to be under the system configuration, and all of this stuff is going to fall under Tracker. All right, so to apply a tracker to an interface, we have to configure it in the VPN interface, whether it's a cellular interface, Ethernet VPN interface, a NAT pool interface, or a PPP interface, but we have to do that in those particular templates. So this is an example where we have to set up a feature and then apply the feature to another template, which we call kind of nested template configurations. And that's probably one of the challenging aspects of configuring templates for the first time, is there are some dependencies that exist when you're going through and you're configuring these templates, where you have to actually configure one template before you start to modify or configure other templates. Some of the other advanced features that you're going to see and some of them might be on the screen here, some of them might not. So if you're not seeing them on the screen, they do exist under this configuration. All right, one is called the control session policer rate. That basically specifies the maximum rate of the DTLS control session traffic, basically policing it based on packets per second. And that goes anywhere from 1 to 65,535, so that's a 16-bit value. And default in that case is 300 packets per second. You know, a lot of these defaults we don't typically change or tune unless we run into a specific scenario where we would need to modify these individual parameters. The MTU of the DTLS tunnel, right? This is where we can specify the actual MTU size of the DTLS tunnel that we're sending our control traffic between the different Viptela devices in the SD-WAN fabric. This is going to go anywhere from 500 to 2,000 bytes. The default is going to be 1,024 bytes in this case. Now, we did talk about port hopping earlier in one of our earlier lessons when we were talking about establishing the control plane security and managing the control plane. So we do have an option of modifying some of the port hopping behaviors. Is it turned on or is it off? What is the offset and so on? If we click on, that's going to enable the port hopping feature. If we click off, it's going to disable it. Let me just kind of refresh what this means, right? When we have a Viptela device that's behind a NAT, port hopping rotates through a pool of pre-selected OMP port numbers, which are called the base ports. And these are used to establish the DTLS connections with other Viptela devices when the connection attempt is unsuccessful, meaning that we maybe have some duplicates or whatever. Those default ports are 12,346, and then they increment by 20 by default, up to 66, then 86, then 12,406, and then finally 12,426. So we can modify the base port, we can set the offset value, we can actually disable port hopping on a per tunnel interface basis or an individual TLOC basis, and we would use the VPN interface Ethernet template to configure that. So by default, this port hopping feature is going to be enabled on vEdge routers, and it's going to be disabled on vManage NMSs and vSmart controllers. The port offset, that's basically the number that we're going to offset the base port number by. This option is going to be configured when multiple devices are behind a NAT device, and we need to make sure that each device uses a unique base port for the DTLS connection because they're probably going to be ending up using the same IP address. This particular value goes anywhere from 0 to 19. We can set the DNS cache timeout. This is basically the timeout for the vBond orchestrator address being cached in the device itself. The default is 30 minutes, which is the max. That can be set from 1 to 30 minutes. I don't recommend changing that, but maybe there's a scenario where you want to time out that information because the vBond orchestrator information might be changing on a regular basis, which it typically doesn't. Track transport, we would select this, turn this on or off, basically to regularly check whether or not the DTLS connections between the device and the vBond orchestrator is up. If we disable this, then we would disable that checking feature. By default, it's enabled. All right. Again, probably not something that you'd want to modify. Local vBond. That's another thing that you would be able to configure under the advanced section. This is only going to be available on vEdge routers that are acting as vBond orchestrators. We would turn that on if we want to configure the vEdge router to act as an orchestrator. And then once we enable that feature, we would specify the DNS name for the orchestrator or its IP address in a dotted decimal format. Track interface, again, only on vEdge routers. We can set a tag string here to indicate which routes are associated with the network. that might be connected to a non-operational interface. And this is a 32-bit value, so again, it goes from anywhere from 1 to 4.2 million, whatever. All right. So whether or not you decide to set all these parameters, it really depends on your specific requirements. Generally, most of the defaults are going to be acceptable, but you might run into situations where you have to kind of modify each of these individual values. Let's see, what else do we have here? We've got multicast buffer. Again, we don't see that. Well, we do see that one on this particular slide. That's basically the percentage of the interface bandwidth that multicast can use. The default is 20%, as you can see here, and that's going to range from 5 to 100%. A USB controller, that's typically only going to be on 1000 and 2000 series devices. If we want to enable it, we turn it on. If we want to disable it, that allows the external USB ports. So we can actually enable the USB controller ports, and we can attach the devices to the a device template to the device. Now this would require a reboot. It's disabled by default. I'm not sure that I've ever actually used that particular feature. Gateway tracking. Here we're going to turn this on to enable or turn it off to disable the tracking of a default gateway. Gateway tracking allows us to determine for specifically static routes whether the next hop is reachable before adding the route to the actual routing table. Something you probably wouldn't want to disable. It's turned on by default. The host, we can see that, right, by this little check mark here to indicate that this is the default value. All right, host policer rate. We can kind of see that right towards the bottom of the screen here. This would also only be implemented on vEdge routers. Basically, we're specifying the maximum rate where the policer delivers packets to the control plane. So this is a control plane protection mechanism. The default value is 5,000 packets per second, as you can see, and that can be set anywhere from 1,000 to 20,000 packets per second. The ICMP error rate, this is also something that's only going to be applied on vEdge routers. How many ICMP error messages a policer can generate or receive. The default is 100 packets per second. And again, this goes from anywhere from 1 to 200 packets per second. All right. Allow, and we're getting down into the section where we don't see some of these values. Some of the remaining values are like allow same site tunnel. That's going to be a vEdge router specific configuration. Route consistency check, also vEdge router. Collect admin techs on reboots, idle timeout, and echo-friendly mode, which is on our vEdge cloud routers. So the allow same site tunnel option, we turn this on to allow tunnels to be actually formed between vEdge routers in the same site. Now we don't have BFD sessions established between two co-located vEdge routers. There's really no reason to technically have a tunnel between two vEdge routers at the same site, so this is something that's turned off by default. A route consistency check, if we want to verify whether the routes in the device's routing table and the forwarding table are consistent, we can turn this on or off. Collect admin tech on reboot allows us to identify whether or not we're going to collect a capture of information when the device reboots. The idle timeout is an option that you can set as well. How long before the CLI isn't active on a device before the user is logged out? By default, it doesn't time out. So from a security perspective, you may want to set this value. It can go anywhere from 0 to 300 seconds. And then finally, echo-friendly mode. We click on for this to configure the vEdge cloud routers not to use its CPU minimally or not at all when the router's not processing any packets. So that's the echo-friendly configuration. Again, when we apply these configurations, it's going to result in a whole bunch of system-specific configurations that are going to be applied to the device. So the next one we're going to take a look at is the logging feature template. We would do this configuration basically the same as any other configuration. Again, we're going to have device-specific components or global components. For the minimum logging configuration, we have to configure log event notification syslog messages These are going to get logged to the local device's hard disk. And by default, that priority level is going to be set to informational or information. The log files actually get placed in a directory called the /var/log folder on the local device, and then the log files are only readable by the admin user. So to configure logging of event notification system log messages to the local device's hard disk, we select the disk tab, and then we can configure specific parameters. Now, we're not going to see all the parameters listed here, but again, I'm going to talk about some of these values and what these values can be set to. So enable disk, we click this on to allow syslog messages to actually be saved to a file on the local disk. Click it off to disallow it. By default, it's going to be enabled on every single Viptela device in our environment. The maximum file size it is defaulted to 10 megabits per second. As we can see here, that's going to be anywhere from 1 to 20 megabytes. And basically, it's just a syslog file rotation. The syslog files are actually rotated on an hourly basis based on the file size. So when the file size exceeds the configured value, the file's rotated in the syslogd process, and the syslogd process is notified. Rotations enter basically here the number of syslog files to create before we start discarding the oldest files. The default value is here. Here is 10, and this can go anywhere from 1 through 10. Now, the priority is based on standard syslog levels, right? It allows us to set the priority level of the syslog message to save to the log files. The severity level indicates the seriousness of the event that's generated by the message, or that actually generated the message itself. The default priority value, like I said, is informational, but so I guess that means by default, all syslog messages are going to be recorded. The priority levels can be anywhere from emergency, which means the system is unusable, that's going to be level 0, up to alert, means that you have to take an action immediately. That's also going to be kind of important. That's going to have a syslog severity of 1. Critical means that there's some sort of serious condition, which is a syslog severity level of 2. Error means there's some sort of error condition, and it doesn't actually fully impair the system, but it is some sort of error condition. That's going to be level 3. Warning, a minor error condition, level 4. Notice, which is the next level, 5. It's a normal condition, but it's a significant event, right? So it may be something you want to investigate. And then finally, informational, which is a routine condition. This is the default level. Now, when you're dealing with syslog, when you log at a higher level number, it automatically includes all of the lower numbers by default. So by doing an informational logging at level 6, that's automatically going to include level 6 all the way to 0. Now we can also configure remote servers. That's the part that we don't necessarily see here. You can kind of see the server section is blank. You see the little plus symbol here. That little plus symbol allows us to add server information. So if I was to click on this little plus symbol, I would have to configure specific parameters of the server. What is the host name or IP address of the particular device? Typically we try to use IP just so that we're not relying on DNS. What is the VPN ID where the server is located? And that can be anywhere from 0 all the way to 65,530, although typically it's not going to be either 0 or 512 because those are reserved for special purposes. What is the source interface of the log messages? So the interface itself is the outgoing interface that the message is going to be sent from. That could be located in the same VPN as the server. If it's not located in the same VPN as the server, which it has to be, the configuration gets ignored. So we can configure multiple syslog servers, but the source interface has to be the same for all of them. So we would only configure multiple syslog servers if they were in the same group. And then we can specify the priority, right? Again, priority is applied the same way as it is when we're saving it to the disk. We have 0 through 6 and so on. The default priority, if I don't specify it for the server, is going to be informational as well, which is those routine conditions. This is going to end up being saved in our command line, again, under the system configurations, but under logging. So a subcategory of logging, and we would see all the parameters applied there. Now we can use the OMP Feature Template on our vEdge cloud and vEdge router devices or the vSmart controllers. Basically, this allows us to establish the overlay management protocol settings. So we create the template the same way that we normally would. Go to configuration and templates and then create the template. There's a minimum configuration that has to be applied, and then there's some additional options that can be applied as well. From a minimum perspective, OMP is going to be enabled by default, obviously, on all of our vEdge routers, our vManage NMSs, our vSmart controllers. So there's no need to really kind of explicitly configure or enable OMP, but it does have to be operational for that overlay network to function. If we end up disabling OMP, we're basically disabling the OMP overlay network, or the overlay network itself, I should say. What are some of the additional options? The template name, which is the name of the template. Again, that can be up to 128 characters. The description can be up to 2048 characters. Graceful restart for OMP. We want to make sure that that is selected as yes to enable the graceful restart feature. By default, this is enabled. It would be, for example, if for some reason OMP failed or the tunnel went down and we wanted to reestablish the tunnel, we would go ahead and restart the OMP process. We can specify the graceful restart timer. This is basically how often OMP information cache that we store on the device is flushed and refreshed. The timer is actually set to 0 by default, which actually disables the graceful restart, but this can be anywhere from 0 to 600 and something thousand seconds. I can't remember the maximum amount of value, but I think it's over 150 or 160 hours. The default is set to 12 hours in this case, which would be 43,200 seconds. The number of routes advertised. All right, this allows us to specify the maximum number of equal cost routes to advertise. vEdge routers advertise routes to vSmart controllers, and then the controllers redistribute those learned routes, which advertising basically each route to TLOC tuple that we have mapped to those particular routes. Each vEdge router can have up to 4 TLOCs, and by default, it advertises each route to TLOC tuple to the vSmart controller. If a local site has 2 vEdge routers, a vSmart controller could potentially learn up to 8 route to TLOC tuples for that same particular prefix. If the configured limit ends up being lower than the number of route to TLOC tuples, the best route or the routes or the routes that are getting advertised is going to be limited, right? This range can go anywhere from 1 to 16. The default value is 4 in this case. On our vEdge routers only, we can set the equal cost multipath limit, which is the maximum number of OMP paths that we receive from a vSmart controller that can actually be installed on the vEdge device in the vEdge router's local routing table. By default, a vEdge router installs a maximum of 4 unique OMP paths for a particular destination in its routing table. The default is 4. This can be set anywhere from 1 to 32. Send backup paths. On our vSmart controllers only is this what we can set this value. This is not something you would set on your vEdge devices. We turn this on if we want OMP to advertise backup routes to our vEdge routers as well. Now by default, OMP advertises only the best route or the best routes for a particular destination prefix. So if we configure to send backup paths, OMP is also going to advertise the very first non-best route in addition to the best route. It's almost like a feasible successor in this case, like we see with EIGRP. The advertisement interval is how many seconds we pass between sending OMP update packets. The default is 1 second, but this goes, it's a 16-bit field, so it goes anywhere from 0 to 65,535. The hold time is the number of seconds that we're going to wait before we actually close the OMP connection to a peer. If the peer does not receive, in essence, 3 consecutive keep alive messages within that hold time value. So that means that then we're going to consider the OMP peer dead, and we're going to close that particular OMP session or OMP connection. The default timer here is 60 seconds. The range goes from 0 to 65,535. All right. ERO time, this is basically going to specify how long we're going to wait after an OMP session has gone down and then comes back up before we send an end of rib marker. All right, we might talk about that in more detail later on, but EOR stands for end of rib. So when the marker gets sent, any routes that were not refreshed after the session came back up, any routes that are not refreshed after the OMP session comes back up, those are going to be considered to be stale, and they're going to end up being deleted from the route table. This is a 300-second value by default, which is 5 minutes. Again, probably not something that you necessarily need to change. It can go anywhere from 1 to 3,600 seconds, which is 1 hour. All right, shutdown basically allows us to, if no is selected, that means not shut down. That basically enables the overlay network. If we click yes, OMP is going to be disabled and the overlay network won't function. All right, we also have advertise. This is going to be something that's limited to our vEdge routers only. And this basically allows us to identify which router advertising is going to occur based on the routes that are learned locally. So BGP, if we click that on, BGP routes go into OMP. By default, BGP routes are actually not advertised into OMP. OSPF, click on. On is something that normally is selected. Now, if it's an external OSPF route, like an OE1 or an OE2 route, that's not going to be on by default. Only the inter-area and intra-area routes are always advertised into OMP. External routes are not advertised into OMP. So by clicking on and then clicking on again in the external field, that will allow us to advertise external OSPF routes into OMP, which would be, you know, routes that originated by an ASBR in your OSPF domain. Connected, if we want to disable advertising for connected routes, we click off. By default, connected routes are going to be advertised. Static routes also by default are going to be advertised, and so on. Now we would configure something like this on a per VPN basis. So we would have the per VPN route advertisements, meaning that we would apply this configuration to our VPN feature template, which we'll see maybe possibly later on. Discard rejected. This would be something that would only be implemented on our vSmart controllers. Click yes here if you want OMP to discard routes that have been rejected on the basis of policy. Right? By default, rejected routes are not actually discarded. Now, just because a rejected route is not discarded doesn't mean it can be used. Policy still determines whether or not a particular route can be used. All right. We have a couple more that we're going to talk about here, and then we'll get into the wrapping up this lesson, and we'll move on to our next lesson. The next one we're going to talk about is the security template. This can be implemented for all the devices in our environment. On our vEdge cloud and vEdge routers and on our vBond orchestrators, we would use this template to configure things like IPsec for the data plane security. On the vManage NMS and on the vSmart controllers, we would use this template to configure the DTLS or the TLS control plane security features. All right. Now, there are parameters that are required, and there are some optional parameters as well to configure the control plane connected protocol, say for vManage and vSmart. The template name, the template description, as always, 128 characters or 2048 characters. The protocol, right? We only have two options in this particular case. This allows us to identify the control plane connections that we're going to use. DTLS, which is the default, the datagram transport layer security, and TLS, which is not the default, transport layer security. Remember, one is UDP based and one is TCP based. Then we can specify the TLS port. The range can be anywhere from 1025 through 65,535. The default in this case, we don't see it here, but it's 23,456. All right, now for data plane security options, we have, those are all the control plane security features. For the data plane, we still have the same options. We configure the template name, the template description, and then we can specify the authentication type for the IPsec. Now, authentication type can be one of four things. We can do AH, authentication header with SHA HMAC, which enables SHA-1 HMAC and ESP HMAC SHA-1. We can do AH no ID, which basically enables a modified version of AH SHA-1 HMAC and ESP HMAC SHA-1 that ignores the ID field in the packet's outer IP header. We can also do none if we decide that we don't want to do any authentication. Or finally, we can enable SHA-1 HMAC, which enables ESP HMAC SHA-1. That's pretty typical to what we're going to do in most of our deployments. We're going to enable the authentication type of SHA-1 HMAC. So that's what we're seeing on this particular slide, authentication type. We would obviously want to scroll through all of these configuration options to specify it. But just keep in mind, there are different security templates that can be applied, one for the control plane and one for the data plane. We see a rekey time as well. This is an optional value, basically how often the vEdge router changes their AES keys that are used to secure the DTLS connection to the vSmart controller. If we have OMP graceful restart enabled, the rekeying time has to be at least twice whatever the value of that graceful restart timer is. Make sure that you specify that. The default is 24 hours because the default rekeying graceful restart timer is 12 hours. Now this value can be anywhere from 10 to 120, 1.2 million, excuse me, which is like 14 days or something like that, okay? The replay window specifies the sliding replay window. The default here is 512 packets. And that can be implemented in powers of 2 increments from 64 all the way up to 8192, 64, 128, 256, and so on. All right. Now, if we save this configuration, the resulting CLI configuration is going to go under the security group, right? And we would either see security control for all the control plane configurations, or we would see security IPsec for all the IPsec configurations for the data plane. Now, the last specific one that we're going to talk about in this section is the BFD Feature Template. We're going to use a BFD template for vEdge Cloud and for vEdge router devices. The BFD protocol, as we've talked about, is what allows us to detect when link failures occur if we have a high availability solution in place. It's going to actually be enabled by default on all of the vEdge routers, and you can't actually disable it. All right. Now, there are some specific parameters. We could configure BFD for application-aware routing, for example, which means we can set up the timers that are used by the application-aware routing feature. We go into the multiplier, or we can set the pole interval. We specify the value for multiplier basically on, it's a multiple of the pole interval to kind of set how often application-aware routing acts on the data plane tunnel statistics to figure out the loss, the latency, to calculate new tunnels if those latency time values or loss values don't meet our configured SLAs. In this case, the default is 6, and it can be set anywhere from 1 to 6. The pole interval specifies how often BFD poles, basically all the data plane tunnels on the vEdge router, to collect that information, that packet loss, the packet latency, other statistics that are going to be used by application-aware routing. This is a 32-bit value, so it can be anywhere from 1 to 4.2 million, and the default is 10 minutes, which is 600,000 milliseconds in this particular case. When we save those configurations, those are going to go under the BFD app route section under our command line. Now, we can also configure BFD on our transport tunnels. These are the timers that are used on the transport tunnels. And in this particular case, you can kind of see it at the bottom of the screen here. We can choose the color, we can choose the hello interval, we can choose the multiplier, path MTU discovery, and so on. All right, so if I was to choose the color, we choose the color of the transport tunnel where the data traffic is moving between the vEdge router. Basically, the color identifies the specific WAN transport provider. We could have 3G here, we could have Biz Internet, blue, bronze, custom 1 through 3, default, gold, green, MPLS, private 1 through private 6, etc. Whatever all the different values are that exist by default in the system with regard to colors. The default is just default in this particular case. We can also specify the hello interval, how often we're going to send BFD hello packets on the transport tunnel. BFD basically uses these hello packets to detect the liveliness of the tunnel based on these hello packets being sent and responded to, right? So that range is going to be anywhere from 1 to 60,000 milliseconds, but the default is 1,000 milliseconds. The multiplier allows us to specify how many hello packet intervals BFD waits before it decides that the tunnel has failed. When BFD declares that a tunnel's failed, it basically is because it's not receiving any hello packets on the tunnel. So this basically is an interval multiplier of the hello packet interval time. For vEdge routers, it's going to be 7. For vEdge cloud software routers, it's going to be 20. All right, our path MTU discovery, we can turn this feature on or off to enable MTU discovery for the transport tunnel. If we have it enabled, the PMTU feature enabled, the path MTU for the tunnel connection gets checked periodically. I think it's about once every 60 seconds or so, and then it gets updated dynamically. If we have the feature disabled, the expected tunnel MTU size is going to be just assumed to be 1472 bytes, but the actual effective tunnel MTU is typically going to be about 1468 bytes. And this is going to be something that's enabled by default as well. So we can click Add to save those individual configurations, and we can use the plus symbol to continue to add additional ones. All right. So if we want to add a color, we can add a color, and then the color is what's going to have the hello interval, the multiplier, the PMTU discovery applied to it. That's going to show up under the command line as in the kind of the global syntax as BFD color, and then we'll have the color listed, and then we can see the properties for each of the colors that are applied. All right, now we do have other feature templates that are available, and obviously the time in this class, we don't have a whole lot of time to go through every single feature template that's available. There's Cisco documentation on each of these, but we can provide feature templates to configure SD-WAN devices in our overlay network for all kinds of features, right? We know that some feature templates are mandatory, some are optional. Each of the mandatory feature templates, even some of the optional ones, do have factory default templates applied. So we can see some of the other feature templates that might be available: AAA, BGP, cellular profile, multicast, NTP, OSPF, VPN, etc. I would recommend, if any of these might apply, or if you suspect that any of these different feature templates apply, that you go out and look at the documentation to see what each of these feature templates include. And of course, you can go to the software documentation to see what each of the values are represented by each of these other templates. All right, so in this lesson, we talked about the system feature template. We went through in detail what each of the values represent: the logging template, the OMP feature template, the security template,